So in this lesson, we are going to learn about what are the numerical ways that we can measure the spread or the dispersion of our data set. So we do have these three measurements. Well, the very first one is called range, and we have variance and standard deviation. So actually standard deviation is a simple derivation of the value variance, and standard deviation is the most commonly used numerical measurement to measure the spread of a data set. And then we have some other measurements such as percentiles and quartiles. So we are going to learn what these measurements are, and we will see how do we calculate them. So before that, let me go back and talk about what we did, like in converting a data set into a graph. So the graphical summary. So where can we find this idea of spread of the data set? So as you can see here, you have your original data set. Over here, this is your original data set. Okay, so you have 25 data points, and what we do is we convert this data set into a table first, right? You have classes, so 20 to 30, 30 to 40, so and so, and then you count how many data points in each class. So we have 6 data points from your original data set that falls between 22 and 30, and then we have 8 data points in our original data set which falls between 30 to 40, so and so, right? And then we have the percentages done. And using this table, we just put this table into a graph and we call it histogram. So on the x-axis you have the intervals 20 to 30, and then 30 to 40, so and so, 40 to 50, so and so. And then on the y-axis we can have either the frequency or the percentage. So in this case we have the frequency. So from 20 to 30 we have 24% of the data, and then from 30 to 40 we have 32% of the data. 2% of the data, so and so, right? And then we can derive the frequency polygon from histogram. So what we do is we simply take the midpoints of each vertical bar and we join them. So that's how the frequency polygon is made. So once we have this picture, we need to understand that this picture demonstrates the original data set. So we went from here all the way to this picture, but this picture is actually our data set, a graphical representation of our data. Okay, so so when you have a data set and now we need to measure or capture two information of our data set numerically. So when you numerically present your data set, you need to think about where does the center lies, where is the center of my data set, and how about what is the spread of my data set around the center. So you have to look into the center. Center means 50% of the data should be below that number, 50% of the data must be above. So when I look into these percentages over here on the frequency distribution, if I add the first two, if I add these two, first two percentages, those two are around 56, right? So 56%. So that means 56% of the data are between 20 to 40, and then the rest of the percent amount is from 40 to 70. So basically the center is somewhere around 40. So 50% of the data are below that number, 50% of the data are above that number. So center is somewhere here. Okay, so we have three ways to measure the center: mean, median, and mode. So based on the data set and based on whether we have extreme values or not, we can choose one of these three measurements to numerically measure the center of our data set. And then we are going to measure the spread. In this video, we're going to talk about how do you measure the spread and what is this spread. So spread can be either the complete spread of the data set. So in this case, starting from 22 all the way up to 70. So this could be the complete spread of your data set. So we can measure it that way, in that perspective, or else you can think about it as the spread around the average. You can say, I want to measure the spread around the center. Okay, so either ways we do have the measurements on that note. So range, let me go back here. Range is actually the complete spread of the data set. So if you think about range, it's very easy to calculate. So the complete spread is just the difference between minimum data point and the maximum data point, right? So range is simply maximum value in your data set minus the minimum value. So the range is not a powerful measurement because if you have extreme values, it is going to get affected by extreme values. So you have some extreme values over here. So the complete range is this, right? So this complete range is going to get impacted by the extreme values, where actually the most of your data are here. So your actual range is something like this. This might be the actual range, but due to the extreme values, you ended up having a longer range than it should be. So range may not be the best one to use to talk about the actual range, actual spread. So because of that, range is not that popular. So the one which is popular is standard deviation. So standard deviation, is a simple derivation of the variance. So the reason that we have to use standard deviation instead of the variance is because of the unit problem. So the variance, the way we calculate the variance, it comes as a squared value. So variance, if you calculate the variance of a data set of incomes, I'm just taking an example. So we have a list of incomes and I calculated the variance. So variance is going to be a value like let's say $10,500. The unit is dollar square. So variance is a squared value. So we use all the data points and we square those data points in the calculation. So it's a dollar square value. So when you think about a dollar square value, it's very difficult to interpret. What does that mean in terms of the spread? So that's why we use standard deviation, because standard deviation is the square root of the variance. So this connection is extremely important. You need to know the relationship. So standard deviation is the square root of the variance. So then we solve that unit problem. So you have to just calculate the square root of, for this example, 10,500. And we know when you calculate the square root, the unit becomes just dollar, right? So then you can easily make an interpretation using this value. So because of that reason, we always use standard deviation in terms of the interpretation part. And you need to know, how do I get the standard deviations? By calculating the variance and then taking its square root. And we're not going to use formulas. I'm going to show you how to get this done in Megastat. Okay, so standard deviation. And then the third one, percentiles and quartiles. So they are considered as other measurements of dispersion. So percentiles is actually the general case. Quartiles are just some special cases of percentiles. So I'm going to start with quartiles, and then we'll generalize the idea of percentiles. So when you have the frequency polygon, just again think about the frequency polygon, or you can think about your data set. So on the x-axis, you have your variable or your data. So I'm just going to go with, let's say, income. I have a set of incomes, and then I put that data set into a graph, into a frequency polygon. And on the y-axis, let's say that we have the percentages, which means the frequencies, right? So if I have a shape like this, so fairly symmetrical shape, right? So if I divide this into 50-50, so this is the center of the data set, and we know if you have a symmetrical data set, this is actually mean, right? The mean equals to median equals to mode. All three of them are the same for a symmetrical data set. So what this number does is that it divides your data set into two equal pieces, right? So same amount of data below the mean, same amount of data above the mean. For example, if you have let's say 20 data points, the idea means 10 data points are below this number, 10 data points are above this number. So that's the idea of the center, the right midpoint. And then you can further divide these two halves again into another two halves. So if you want to divide the left half of your data set again into another two pieces, let's say from here. So this is going to divide this left 50% of the data into 25% and 25%. And then the right hand side, another half, the upper half again can be divided into 25%, 25%. So these 3 points are basically going to divide my data set into 4 equal pieces, right? So if you have 20 data, so each area you have 5 data points. So in this area you have 5 data points. Again in this area you have 5 data points. This area you have 5 data points. 5 over here, 5 over here. So that's the idea of dividing your data set into 4 equal pieces. So, and the interest over here is which point divides your data set into those 4 equal pieces. So these points are called quartiles. So this one is called first quartile, Q1. This point, the mean, the median, mode, they're all the same for a symmetrical distribution, but not necessary for any other shape. This point is actually Q2, second quartile, or the median. Because median divides your data set into halves, right? So second quartile equals to always, no matter what the shape is, second quartile equals to the median. And then the third point is called Q3, third quartile. So once again, Q1 first quartile, Q2 second quartile, Q3 third quartile. So if you just think about a different frequency polygon, if you have a different shape, a skewed shape like this, so median can be somewhere here, the midpoint 50-50, that means this is Q2, the median, and then this is Q1 and Q3. So each piece must have 25% of the data. Okay, right. So that's the idea of quartiles. So quartiles divide the data set into 4 equal parts. Okay, and then generalizing this idea, we get percentiles. So for example, I can rewrite these quartiles in terms of percentiles. So as you can see, Q1, first quartile, below the first quartile, you have 25% of the data. So I can write down 25% of the data are below Q1, right? And then I can write down another statement about Q2, because I know below Q2 I have 50% of the data. So half of the data are below Q2. 50% of the data are below Q2. And I can do the exact same writing with this one. So below Q3, I have 75% of the data. 75% of the data are below Q3. So this is the idea of actually quartiles. So what percent of data below the percentile? So that's how we define percentile. So I can rewrite Q1 in terms of percentiles. I can say Q1, since Q1 has 25% of the data below that, Q1 is actually 25th percentile. And then you have 50% of the data below Q2. So that means Q2 is 50th percentile. And then since we have 75% of the data below Q3, Q3 can be called 75th percentile. So if I generalize this idea of percentile, what it means in a general graph, let's say this is my frequency polygon, and just randomly picking a point over here, and I have, let's say, 98% of the data are below this point. Okay, so then this is 98th percentile. Okay, so if you have, let's say, p% of the data, simple p% of the data are below this point, so this is called pth percentile. So that's how we define percentile. So if you happen to have simple p percent of data below a certain point, that certain point is called pth percentile. Okay, right, so we talked about range, we talked about variance and standard deviation, and the quartiles and percentiles. So let's go back to the Excel sheet and see how we do these calculations using Excel and using Megastat. Okay, so I'm just going to copy paste this same data set from here into a new sheet. Okay, get rid of this highlighting. Right, so this is my data set and what I'm going to do is I'm going to calculate, let's set parts. Part A, I'm going to calculate the range of the data, and part B, I'm going to calculate variance and standard deviation of the data, and part C, I'm going to calculate quartiles Q1, Q2 and Q3 of the data, and then I'm going to calculate in part D, I'm going to calculate, let's just randomly pick few percentiles, let's say 24th percentile, and let's say I want 85th percentile. Okay, so let's do these calculations. So calculating the range, variance and deviation, the quartiles can be done through Megastat. So go to Data tab, Megastat, Descriptive statistics. All the numerical measurements are located under descriptive statistics, because numerically organizing a data set, we know descriptive statistics is about organizing and summarizing a data set, right? So we have mean, so for the moment we don't need that. We have variance, standard deviation, mean max, for the moment we don't need that. I need quartiles, so I'm gonna check this one, and then I'm going to check this plot called box plot. This is something additional, but this is a nice representation, nice graphical summary of your data set using the idea of quartiles. So that's why I just wanted to show you this plot as well. So go ahead and select the data. And since this does not have a range, I'm just going to get min and max, because using min and max I can easily calculate the range. Okay, so click OK. There you go. So okay, well, even though the range was not on the list, it has been calculated in the output. So range is 44. So the complete range of this data set is 44. And then variance and standard deviation, I'm just going to copy paste it. So as you can see, variance is a very high number, right? 148. Your data points are 2-digit numbers, right? So obviously this is like a squared value. The variance is a squared value, which is not good. We cannot easily interpret the idea when you have it in squared terms. But standard deviation, this is good. So the standard deviation is 12.19. So what this means is that you have around 12.19 spread around the mean. So the standard deviation is actually measures the spread around the average. Average of the data. Okay, so 12.19 is that amount. And then we have quartiles, Q1, Q2, and Q3. So Q1 is 32 and Q2 is same as the median. So this is Q2, 34. Q3 is 44. Okay, so if you just imagine the picture, without actually mean, median, and mode, we cannot predict about the shape of the data set, but the idea, you have to get the idea clear. So if you just imagine a random shape for this picture, for this data set, something like this. So first quartile somewhere here on the x-axis. So these numbers are on the x-axis. 32, this is Q1. And then second quartile, the median, 34. This is Q2. And then the third quartile is 44, Q3. And below 32, you have 25% of your data. Below 34, you have altogether 50% of your data. Below 44, altogether you have 75% of your data. Okay, and then the percentiles. So percentiles cannot be done through megastat. So we have to use an Excel function called percentile. So it's very easy to remember. The function name is just percentile. So we are going to use an Excel function called percentile. Okay, so this is how you add an Excel function. So every function, every formula starts with an equal sign. So you type equals and then you start typing the function name. So since the function name is percentile, start typing it. Then everything starts with these letters will pop up, and from this list you have percentile.exe, percentile.inc. We just need just the percentile. So this one, the second last one, right, in my list. So just double click on it, move the mouse pointer towards that, double click on it, then you will see the function name will be added and brackets will be open. So then you have these instructions down here. What do you need in order to calculate this percentile? So let's say I'm calculating the 34th percentile of this data set. So first thing, array means your data set. So you can see the cursor is blinking right after the bracket. So that's where it should be. And all you have to do is you have to go back to your data set and simply select it. Okay, so then you can see the cell referencing has been copied over. So my data set is from A2 to A26. So either you can select your data set, or you can look into the cell referencing, and then you can type it on your own. So you can just type A2 colon A26. That'll do. And then comma. After that, you have to add a comma. And then you have to let Excel know which percentile am I calculating. What is the percentile I need? Because it can be 100 different percentiles, right? Starting from 1th percentile to the so and so, right? So I'm calculating 34th percentile. So don't type 34. This is percentages we're talking about. So type the decimal 0.34. So this will give us 34th percentile. So 33. So I'm going to add 34th percentile is 33. Okay. So on this picture, you can see that we have over here. So 33 is here. And as you can see, it has 34% below that number. 34% of the data are below value 33. And then similarly, you can calculate the 85th percentile. So equals percentile, double click on the right function, and then select your data set or type it. So this time I'm going to type it. So A2 to A26. That's where my data is, comma. I need 85th percentile. So 0.85. Enter 54. So that means from the picture, so 54 is somewhere here on the x-axis. So below 54, I have 85% of the data. 85% of the data are below 54. Okay, so once again, range is the complete total range, total spread of the data. And then standard deviation talks about the spread around the mean, okay, around the average, measures the spread around the average. And then the quartiles, we have 3, Q1, Q2, and Q3. Basically divide your data set into 4 equal pieces. And then the percentiles are the generalized version. You can calculate any percentile using the Excel function percentile. Okay, so these are the measures of spread. And then the last one that I'm going to discuss, last topic, is the box plot. So as you can see here, I got this using Excel. So this plot gives us a basic idea about the shape of the distribution. So as you can see, it has a rectangle, and inside the rectangle you can see a vertical line, and then to the sides, on the 2 sides of the rectangle, you have 2 horizontal lines. We call them whiskers, and the left side whisker goes until the minimum data point, and the right hand side, this dot over here, this means an extreme value or outlier. So we have an outlier in this data set. Okay, if there are no outliers, usually this whisker would extend all the way up to the maximum data point. Since we don't actually talk about outliers in this chapter, I'm just going to go with, okay, so the two whiskers extends until min and max. And this vertical, the rectangle consists of the quartiles. So this side is actually aligned to Q1, and this middle, the bar inside the box, is aligned to Q2, and this one is aligned to Q3. So that's how the box plot is made. So if I go back and recreate, so 22 is the min, right? So 22 is the min, 66 is the max, 32, 34, 44. So these are the numbers we use to create our box plot. Right? So basically this helps us identify the shape of the distribution. Is it skewed? Is it symmetrical? So if you have like a perfect symmetrical shape like this, when you create your box plot, the underlying histogram or underlying frequency polygon would look something like this. Symmetrical. Okay, and if you have like a skewed shape, let's say the left whisker is shorter compared to the right whisker, something like this. So you can see the box is not completely aligned symmetrically. The box is towards your left hand side, so the underlying shape is this. So majority of data are here and some extreme values are to the right hand side. So you have a skewed to the right. So this is positively skewed distribution. And then if you have the other way around, so the left whisker is longer compared to the right whisker, underlying shape is the complete opposite. So you can see, so this is a distribution with a negatively skewed pattern. So the data is leaned towards the left hand side. Most of the data are on the left hand side, and we have some extreme values on the other side. Okay, so box plot, rather than creating the histogram or frequency polygon, because creating histogram or frequency polygon, you have to do a lot of work, because we have to first create the frequency distribution in order to get the frequency polygon, right? It needs a lot of work. But this is a very simple graph. All you need is min, max, Q1, Q2, and Q3, right? So this is min, minimum data point. This is Q1, Q2, Q3, and maximum. That's all you need, right? On the x-axis, you mark them and you just simply draw this simple diagram. So by looking at its symmetry, you can talk about the shape of the distribution. So it's something easier to create if you don't want to create the histogram or the frequency polygon of your data set. Okay, so this lesson talks about measures of spread, right? So like I said, we have 5 different ways of measuring the spread of a data set, and we have gone through those and how do we calculate them. So once you complete this lesson, and the next thing you should do is go ahead and try some questions from the worksheet.